Here we go. Hello, everybody. Welcome to today's Edge Analytics, the next frontier in smart business, presented by Mike Ferguson. My name is David Sweener, and I am the Global Product Marketing Leader for Statistica. I have the extreme pleasure today to be your MC. Before we get started, here are a couple things to keep in mind during the presentation. This webcast is being recorded, and the recorded version, along with the presentation materials, will be sent to you in a follow-up email early next week. We will conduct Q&A throughout the presentation, and it is our goal to make this productive in your time. So please enter your questions in the Q&A box. We'll get to as many of those as possible. You can enter a question at any time. I'll take a minute to introduce our topic and our presenter. With the Internet of Things, we're all well aware that there are tremendous volumes of data that are emitted by various sensors and devices throughout the world. When you look at articles on machine learning and data science, they are generally centered on data stored locally. So to address this gap, Mike is going to talk about streaming analytics at the edge. I am the MC. I am calling in from the Green Mountain State in Vermont, United States of America. We just got 20 inches of snow. And our presenter today is Mike Ferguson. Mike is calling in from England. He is the Managing Director of Intelligent Business Strategies Limited. Mike has decades of experience in analytics, AI, and database technology. He regularly consults authors and speaks all over the world, and we're extremely happy to have them. And with that, Mike, the floor is yours. I will pass the ball to you.
Okay, Dave, thank you very much indeed. Hi, everybody. Many thanks for joining us today, taking time out of your busy schedules wherever you are. Good morning, good afternoon, or good evening. I've just shared my application with you here. Hopefully we're seeing that. So what I want to skip over my intro a bit here, but if anyone wants to contact me later, please feel free to do so, and I'll do my best to answer any questions we don't get through here today. What I want to talk about is the modern analytical ecosystem that's emerging in a lot of organizations today, and then within that, switch to focusing on a specific kind of data and analysis that's going on within it, which is, of course, the aspect of fast data, and what's driving that. To look at the explosion of data that's happening there and all the things that are potentially emitting it. And then the kind of use cases for that. Then what we're going to do is look a little bit about how streaming analytics works, which is really the application of trained machine learning models and stream processing on continuous data flows that are coming in from outside the enterprise or that are being generated within the enterprise. And then we're going to look at a question that I think a lot of people are beginning to ask now, which is, we have technologies available today to deal with streaming analytics. And in fact, the heritage of this has come from Wall Street many years ago, when we had the emergence of something called complex event processing software, and we've seen that advance over the years. But it's always been the case about bringing the data to the middle before you can kind of analyze it on these scalable analytical platforms. And I want to explore that, but then I really want to ask the other question, which is that going to scale? Yes, we have scalable computing environments now, and you might say, well, yeah, we can expand these clusters and whatnot, but really, do we really want to bring everything to the middle and analyze it on a scalable platform, or is there opportunity to push the analytics out into the network or the edge, if you like, and run those analytics closer to where the data is potentially being generated? So if you look at the kind of analytical ecosystem today, some of you may have all of this, some of you may have some of it, some of you may have gotten into big data, some of you may not. But the point is that today, we've gone way beyond data warehousing. we're into multiple different kinds of platforms that are optimized for different kinds of analytical workloads. And whereas data mining back in the 90s was very much focused around relational databases and to some extent analytical relational databases, the kind of MPP platforms. Today there's a big shift in focus to even more scalable analytics on other platforms, including things like Hadoop or in-memory analytics on Spark. And then there's other different kinds of analytical data store and NoSQL data stores like graph databases, where we may want to be doing graph analysis. We also have unstructured information like text, where we'll be doing text analytics, which can be done in a couple of ways, one of which includes machine learning, one of which is more of a lexicon-based approach. But what I want to focus in on is this one, the real-time streaming analytics piece. And as you can see, I've left a kind of other red call out there around model development on big data platforms. And the reason for that is that I may train and build models, typically machine learning models, to predict things, for example, in that environment, but then I may want to deploy them to execute in a real-time streaming environment to the left of that. So this is a world which is fairly new to a lot of us. Maybe not to investment banks who've been heavily involved in this for a long, long time, but for a lot of companies yet we're still learning about this kind of approach, which is very different to what we've ever done before. And I use the definition here, which I just liked. It was a pretty simple explanation that fast data or streaming data, you hear these terms used interchangeably these days, it's high velocity data that's being generated at a very, very high rate or arriving at a very, very high rate. And so it's data in motion. It's streaming into applications and computing platforms from maybe hundreds of thousands or even potentially millions of endpoints. And the idea here is that we are able to ingest it, pre-process it in some way, and analyze it all before it's stored anywhere. And if there is patterns within that data that are potentially of interest that we want to then filter out and store for later use, then we can potentially do so and go do further offline analysis. So a good example here might be if you get a prediction in real time that a piece of equipment is likely to fail, then I may want to take action on that, but at the same time then filter that pattern into a big data environment and then go back over the last couple of months and say, well, how many times did that fail? Is that happening as a one-off or is this happening on a regular basis, in which case, just taking a one-off action isn't enough. We've got to do something a bit more significant than that's going to get to the bottom of the problem. And so all kinds of fast data or streaming data. We've got authorization systems, which would want to be checking things. The financial markets I already spoke about. Machine data that's often in log files. So web logs are log files on web servers that, of course, capture every click that's going on a particular website. And for some websites around the world, that's huge amounts of data happening and being captured on a continuous basis. We can get streaming data off of mobile devices through GPS sensors, for example, to say where you are all of the time. And other kinds of sensors as well installed in industrial equipment, in all kinds of products. We're seeing, of course, lots of discussions about things like cars and aircraft and whatnot, all of which are mounting up to forming the concept of Internet of Things that are capable of emitting data on a continuous basis. And of course, as well, social media, if we wanted to tap into, say, the Twitter fountain as it actually happens, maybe to continually monitor sentiment around products or brands. We could potentially treat that as fast data as well. But I guess the Internet of Things is going to take this to another level, where we end up with billions of devices emitting data. And of course, there could be industrial internet kinds of pieces of equipment and whatnot that would emit data, or they could be consumer-related products and that could be emitting data that could then be analyzed or viewed by the consumers themselves. But at the bottom, behind all of that, really is sensors. And these days, we have sensors to, monitor everything from temperature, light, vibration, movement, location, pressure, all of that. We've seen some examples here. We've all seen the request for permission on our smartphones to be able to find out where we are, so that we can capture that information as you move around. That's of course done by a GPS sensor in your smartphone. But increasingly now, if you look at everywhere you look, the amount of data that's being generated is significant. I've taken one here from the aviation industry. As you can see here, Rolls-Royce have got aircraft engines with a sensor network or a sensor pack built into it, recording everything going on in the engines, and taken two models of the Airbus A350. The A350 today is generating 2.5 terabytes of data per day for one plane, but the new model due out in 2020, that's going to treble. So 7.5 terabytes of data coming off a single aircraft per day. You imagine how many planes flying around over the next 5-10 years, how much data that's going to be spewing out of them as they go about their daily flights. And of course, sensors aren't just going to be in one part of the plane, they'll be all over it, right? So you can just imagine the amount of data that could be potentially coming out of something like that. Or connected car. Again, it's not just the sensors that stop us bumping into things when we're trying to park, but the sensors all over the potential vehicle to monitor all kinds of things going on whilst we're driving. And it's not just stopping there, it's all the way down to wearables now. We've got things like Fitbits or iWatches, or in healthcare, with various devices that we can attach even into watches like that and record various kinds of data about our vital signs and whatnot, all of which can be potentially gathered and transmitted for further subsequent analysis. So what are we doing with it all? Probably two broad ways in which to divide up these kind of use cases is monitoring things to prevent something happening, to prevent fraudulent transaction, to prevent a network outage or a piece of equipment failure, to prevent stockouts on the shelves of a retail store. All kinds of things like that. Or the alternative is to optimize it. So if something's not running particularly well within your business operations, maybe there's a bottleneck in the production line, then we want to be able to detect that quickly, or even predict that it's going to happen and be able to take preventative action before it does. And similarly with field service, optimizing field service in order to do preventative maintenance on equipment. All of that could come out of monitoring equipment in real time and predicting that there could potentially be a failure. And so we're able to take action before it actually happens and causes major outages, which of course could be very costly for everyday business operations. And there's a raft of applications here, just some examples of different verticals. Again, supply chain optimization, location-based advertising on mobile phones in retail. In airlines, I already kind of mentioned a little bit about that. All monitoring equipment, manufacturing production lines. Telco is monitoring the health of the cell phone network, so they don't get any outages in maybe highly populated areas that could lose them a lot of money. Um, there's tons of opportunity here with all of this going on. But the bottom line is it's spewing out continuously data coming at us that we need to potentially analyze. And within those storms, if you like, of streaming data coming in, all those events that are being emitted by all of those sensors, for example, there are patterns. And there are complications around this, like, for example, that these events may not turn up in a sequence. They may turn up out of sequence, and so we have to be able to deal with that. There may be multiple instances of the same thing within the same event storm. So we have to distinguish the fact that there are multiple instances of the same pattern. And then there's, of course, the arrival rate of this data is significant. And so, we've got to be able to find a way to look at this data on the assumption that something's very different here. Whereas before in data warehousing or even certain kinds of big data analysis, we would be extracting data, storing it, and analyzing it. Here, we're dealing with a data source that never stops. And so we have to deal with the fact that we're not pulling the data so that we can then analyze it, but the data is being pushed through, if you like, an analytical engine in order to be able to look at it. And often that data is time series data. It doesn't have to be, but it's often time series data, in which case we can then put a window on that data and decide how we want to, the size of that window. We can make different choices as to that. And within that window, we're going to look for patterns using continuous queries that would operate on the data as it flows by. And of course, the size of the window could vary. And of course, the larger the window you're going to have, the more memory you're likely to need and scalability you're likely to need to be able to look across a bigger window. If we decide to, change it from 5 seconds to 1 minute to 10 minutes, then clearly that's a lot more data that we have to be able to hold, to be able to look for the patterns within that time frame. It could be longer, of course, but the point being is that we can vary the size of this window in order to analyze. And of course, the goals of this kind of analysis are to perhaps identify trends. Is something going up or down? Is there some kind of pattern emerging here, or some outlier that doesn't look right, that could be fraudulent, for example, or is there just some complete change in maybe opinion or in business operations that would clearly signal a significant problem? We might want to be able to forecast things to see what something's like in the near term. We might want to be able to do this in order to take preventative action. I mentioned, for example, the equipment failure and preventative maintenance in order to optimize a field service organization so that we don't get unexpected downtimes and things like that. Or it may be to identify problems maybe in a production line that could affect product quality, could affect timeliness of deliveries and whatnot. So streaming data, is something that's kind of different. If you take this classic architecture for a data warehouse, which most of us should be familiar with, but it's been around for the best part of 20, 25 years, where you're extracting data and dropping into staging areas, doing the transformations on that and making it live for data warehouses and subsets of it going out into data marts. Something that we've been practicing for years, but then you get continuous streaming data coming along, and we're not extracting it. It's coming at us all the time. So then you kind of say, well, if I have to respond to that kind of data and analyze it, well, how does it fit with this classic architecture? I mean, do I put it into the staging area? Well, is that going to work? And the answer is probably not, because if it has to go to the staging area, then out of there through ETL processing into a data warehouse, then out of there into a data mart before a BI tool gets it, then there's too many databases and it's too long to respond. And so the classic architecture just doesn't work here if you're going to be able to be responsive and take actions, whether those are manual or whether they're automated. It's not going to fit with this kind of architecture today. It's a different approach to analysis. So what we have to somehow do is bring in streaming data and maybe integrate it with other enterprise data like master data or data from a data warehouse in flight, and then do in-flight analysis and some kind of in-flight decisions on it in order to then drive actions, whether those actions are to drive alerts to BI tools or mobile devices or even invoke other applications, or maybe, and also filter data of interest into data warehouses or into big data platforms for subsequent further analysis. But there's a couple of things when you look at that, and the first thing is obvious, right? Which is this whole thing needs to scale in order to be able to handle the pre-processing of streaming data, the in-flight analysis, and the decision making. We have to be able to do it at scale if it's very high velocity data. And the other thing is that it's push-based visualization. That is, it's not the BI tool coming to a database and say, here's a SQL query, give me an answer. What we're getting here is this software is pushing data to the BI tools in order to visualize it. And so BI tools have to be able to handle that, have to be able to have data being pushed at them, and not many tools have done that. Okay, it's increasingly starting to appear, but still today a lot of companies have BI tools that issue SQL requests and get data back. Here we're potentially saying, no, we want the ability to push the data directly to the tool in order to do the visualization. So there's a switch around going on. First of all, the order is different. We've got, whereas classic data warehouse was, prepare and integrate the data, store it somewhere in a data warehouse, for example, in a data mart, and then analyze it using a BI tool, self-service BI tool product, for example, Tableau, Click, whatever. Or alternatively, with the fast data processing, now what we're saying is we want to prepare and integrate the data, then we want to analyze it, and we want to act on it before we store it anywhere. And so, to a large extent, the analysis has to be automated. We can't have a human involved because the velocity of the data is so huge that we wouldn't have time to sit by and have people sit there and watch it all of the time. We need predictive models, for example, that we've developed offline but deployed in real time to be able to do this automatic analysis. And we need some action to happen, maybe a recommendation engine to be able to drive alerts or cause other kinds of automatic actions, and then either a human is alerted and then they act, or a human's not alerted, it's just automatic action. And then at some point later we then store the data. So this is really, truly, analyzing very low latency data at scale and trying to take humans out of the picture. Now, going back to your multiple data stores, whether it's data warehouses with analytical databases or graph databases or big data, we're storing data in those environments. But on the left-hand side, you can see here that we're already analyzing the data before we store it anywhere. And if we then choose to filter something out, we can do so. We can filter it out and store it for subsequent analysis later. But we can also, while we're doing real-time analytics on it, we can drive alerts and actions to BI tools or to mobile devices in order to alert people, or we could even invoke other applications to take completely automatic action with no people involved whatsoever. So the anatomy, if you like, of a streaming analytical application is that we are bringing in high-velocity data streams, one or more of them, filtering out the data we're interested in, doing some cleansing and integration, joining of that data. Maybe we've got data from enterprise systems that we've also brought into and turned that into a stream. We can do that and integrate that with the streaming data. And then we're going to do analysis on the data using some kind of model that's been developed and then interpret the result. But all of this, got a gray box here, is happening in memory typically at scale in order to be able to do this. And so the usual phases of model development apply. We do model development offline, and then we would then build a predictive model that we could then deploy into a real-time environment, which would then execute on that streaming data to analyze it as it flows by, and subsequently to drive any further actions from it. So we would be looking for, stream processing systems to be able to handle what kind of sources and what kind of arrival rates can they handle here. Also, can you analyze what kind of analytics can they support? What kind of extensibility do they have so that you can add further analytical techniques? Perhaps, how is it going to scale? Is there any tooling to be able to develop and deploy these kinds of analyses on real-time data? And then what kind of actions can you take? Where can you put the data afterwards if you want to filter it and look at it later? But the key point to remember here is, we're dealing with velocity. And the last thing you want to be standing right now is on the left-hand side of this chart. So the point is, we're not trying to consume all of this and store it all. The velocity of data could be so large that, we just want to drink from this thing. We just want to let it flow by and look for patterns in it as it does flow by. And then as, the thing scales up, we might open another valve here, and then now the amount of data coming at us is even greater. If you can think of sensors, for example, deploy them more widely across your operations, and the data velocity increases dramatically. So you have to size this thing up and understand how sizable is this? How fast is this velocity in order to understand it? So you need to look at the data sources and understand, what the average throughput's going to be and what the peak's going to be over time, and how's that going to grow over time. And then, are you going to have to partition that data in order to be able to handle it? Are we going to, what kind of things are we going to be looking for? Are we going to have to compress the data, or are we looking for technologies that are going to be able to help do that in a real-time environment? And now we look at the spectrum of how predictive models, for example, are being deployed today. You can get predictions running in everything from spreadsheets all the way up to high-end systems, which, as you can see, include Hadoop, includes Spark, includes, sort of streaming data up there. And so it's a big data use case. And, there's no question that technologies like Kafka are being used in order to ingest data and allow it to be consumed in a cluster so that you can handle scalability at the center. And so it's quite often that you will see fast data with Kafka being used to bring the streaming data in and partition it in order to push it through scalable streaming analytical applications, which can then analyze it at scale. And even getting the situation now where this streaming data can come in and can build sort of microservices-based streaming analytical applications, passing through different phases of pre-processing and analysis, and putting the output back into something like Kafka again in order to build up a scalable analytical application this way. And there's various technologies out there, open source as well as commercial products, that are used for scalable streaming analytics, and they've emerged over time. And I think a kind of a comparison chart here, which I found on the web at the address shown on the slide, that tries to compare things like Storm and Spark streaming and Flink. But the one thing that I would say about this is that the scalability assumption right now is that all of the streaming data, whether it's sensor data or clickstream or market trades or whatever, it's all flowing to the center, to some scalable computing environment to be analyzed. And yet, for a lot of my clients, they're beginning to look at the whole idea of agents or bots that are available to, act as lookout posts all over the enterprise at different levels, looking for different kinds of patterns in everyday operations, so that they can take automatic actions or flag up alerts in order to help them assist people in managing and optimizing everyday operations, to prevent things or optimize things on a continuous basis. And so it's not just, a small number of big analytical applications that we're looking for on streaming data. The potential here is to deploy lots of these agents or bots across the enterprise to be on the lookout for things. And then even to become prescriptive analytics, the ability to not only alert somebody, but even recommend or guide them as to what to do next in order to keep the business optimized, in order to prevent something happening, so that you're not going to get unexpected outages or unexpected unplanned operational costs as a result of something occurring. So let me go back to an example here as to why this kind of thing is important. Now, if I go back to 2010, you probably all remember this. It's the Deepwater Horizon explosion in the Gulf of Mexico that caused an enormous environmental disaster. And this disaster changed the oil and gas industry forever. It really put a focus on health and safety and environmental protection. And since that point in time, something called well integrity has become paramount within oil and gas companies, whether it's gas wells or deepwater oil wells, or even even on land gas wells and oil wells. It doesn't really matter. All of them we're interested in well integrity, and so sensors have become extraordinarily important. Now, if you just look around at some of these numbers, I got these just by looking around the internet for statistics that have been published about just offshore oil wells. Now, these are just offshore oil wells, a lot of the ones that I'm showing you in different parts of the world, but there's a huge number of them. And then you start looking at the number of gas wells, and you think, oh my goodness, just in a couple of areas, there's thousands of them. And then you look at the prediction that we're going to, drill hundreds of thousands more. Now, my question is that if we're going to end up with, 65,000 oil and gas fields around the world and hundreds of thousands of wells, and all of these wells have got sensors in, drilling's got equipment's got sensors on them and everything, are we really going to expect that we should move all of that data to one central place before you analyze it? Would it really make sense to do that? Or could you do it? And then you take connected cars and all the sensors that are potentially going to go in there, and that's going to increase over the next few years. And then you look at that, and then you think, well, how many cars are being driven on the planet in all of the countries around the world? We're talking millions and millions of cars, probably approaching 1 billion cars, all with sensors deployed potentially, not now, but certainly over the next several years, more and more sensors will be deployed in all those cars. Are you going to expect that you would emit all that data and move it to one centralized, massively scalable stream processing platform to do the analysis? Before analyzing it, even if it's analyzing data in motion, we're going to really move it all to one place. Or you take remote patient monitoring. if we got wearables, again, all the people in the world, if we were to try and send that all over the network, are we not just going to swamp it? Could we not do some kinds of analytics and rules closer to where the data is being emitted, and do some local alerts, like like you want to analyze and you discover, that the patient hasn't taken their medication on time, maybe it's not dispensed on time. These are things that why does that have to go to the middle before somebody analyzes it? I mean, even if it's automatic analysis. But if you take a look at, all of the things that you could be emitting data about with wearables, whether it's, things like temperature and some measure of hydration or blood pressure or whatever, being transmitted maybe through the aid of a mobile phone or a smartwatch of some kind, then what do you do if we want to do this with millions, if not billions of people? I mean, billions maybe, but eventually, but certainly millions. And if they've all got these things, and those things are connected, those devices are connected to some gateways, and those gateways are connected to some kind of central analytical capability, is that going to scale? I know we've got very scalable big data analytics, but does it really make sense to try and push all of that data to one huge scalable cluster? Or should we not go back to this spectrum and say, yes, up the top right, we can do scalable streaming analytics, and we can do that today. But what we really need to think about is extending the bottom left and saying, shouldn't the analytics be pushed out into the network, right out into the network, and have them take action more locally? And so we get into the world of edge analytics. And so we're taking action out there. Now, that to me would be way more scalable, because there's a lot of decisions that could happen locally that you don't need to bring to the middle before it's analyzed. You could just take the action locally and it's done. And yeah, okay, some of these other ones may have to be escalated up and whatnot. But the point is that there's an opportunity to push the analytics out into the edge. And so if you go back to this example here, then the question would be, maybe we would like to do central model development of the predictive models and the rules that might drive actions. But couldn't we run the analytics out in the network, out in the gateways, out on the devices, so that they can detect things and take actions there? Of course, we have to figure out where is it best to deploy these things, and for what kinds of analysis would we deploy them out on devices or on gateways and whatnot. But the point being is that we're pushing, I feel like it's distributed execution of models, but it's central development of them. So central development, distributed deployment of the models and rules to go and execute. And so you get into a new concept, which is doing analytics in the car, in the engine, on the rigs, in the equipment, in the wearable analytics, on the aircraft or wherever. You're pushing them right out into the network in order to run close to where the data is being emitted, in order to be able to act as lookouts or bots that would be able to spot patterns that would allow you to take actions to prevent things or optimize things locally, and if necessary, forward them on for escalation if needs be. But there's a big impact of introducing analytics at the edge. I mean, it takes us into a world where we could analyze any data anywhere. It also means that that we are starting to be able to deploy advanced analytics within devices, within gateways, down at that level, which would then say, we need the ability to run analytics on really small footprints and have execution engines that run down in those environments. And we need the ability, we can get more scalability because we're eliminating movement of raw data towards centralized stream processing. If it's not needed there, we get local response, and which becomes immediate, and we can filter and forward on if we need to. And we get flexibility because hopefully we can design this so that we create the model once, deploy anywhere, and so start to come device agnostic. So there are different execution engines that become available to run analytics in these various different environments. On that spectrum that we saw earlier, from the very top, high-end, scalable cluster environments, all the way down to the smallest devices. The point is that we're decoupling where we develop and where we manage these models and where we deploy them to execute. So that we can work across multiple technologies and platforms and start to make use of existing infrastructure. So looking at Statistico, for example, with their edge analytics capability, they can start to do this now. You can start to see that this is an example of a body scanner where you can monitor the equipment and things within it to see if there's any potential parts that may be failing or predicted to fail, in which case you would be able to schedule some kind of alert or action as a result of it. But that we can potentially build these models centrally and then deploy them into the edge or into the network to be able to monitor various things. And here you can see we have multiple deployment options, so that we can generate the models to be in various languages, for example, to be embedded into individual applications or whatnot down at the edge. And in this case, this screenshot shows how I can link it in with something like Dell Boomi, which is a kind of data preparation technology in the cloud, but I can then publish the whole thing, which is the model and this whole pipeline, if you like, as a JVM, and then push it into the edge to run there. Of course, that gives us a lot more new challenges, and I think we have to plan for that. The most obvious one would be, well, if we're going to push all these models out into the edge, then how are you going to know where it all is? How are you going to manage that? We've got to be able to manage that from the center in some way. So, can we do central model development and maintenance of those models and develop the rules that take actions and whatnot on the back of patterns that you may discover? And then can you maintain all of that centrally and have a common repository for these kind of models so that we know, what we've built and we can organize it and keep it in a governed state? And then can we manage versions of those models so that we can know that a certain version of a model is already deployed out there, the new version coming, perhaps because the model accuracy is deteriorating, and we want to then update it and maintain it, and that we know where we have to maintain those models and which ones have to be updated and what versions are already out there so that we can sensibly manage that. And then we want the ability to be able to deploy these models to anywhere throughout the network from a common place, so that we don't have to jump through hoops in order to be able to do that. It should be relatively manageable from a common place that we can control that without getting ourselves flustered and out of sync with and not knowing precisely what we've got out there, and so enter a kind of world of chaos. We want the ability to have multiple deployment options to handle the different kinds of execution environments in which we're going to run, from the high end all the way down out into the edge, to run right down perhaps into particular gateways, particular devices, maybe even right down onto the sensor in some cases. And we need the flexibility to be able to do that, and we need the ability from a central place to be able to monitor model deterioration throughout the network so that we can then see, how to prioritize maintenance of these models, which ones need upgraded and whatnot, in order to keep it fresh and keep it doing its job, so that those lookout posts, those bots that are all out there throughout the enterprise are working away to the best of their abilities to prevent problems, to prevent risk, to optimize business operations, and so avoid unexpected, unplanned operational costs and everything that goes along with it. And then, of course, as well, as I said, we need the models to be able to execute in multiple environments. And so I think we're decoupling the execution environment from the model development environment, so that, why should it be that it's only one vendor has to build all the execution engines here for the vast spectrum of devices and gateways and whatnot in the network that we may want to deploy on. It should be the case that there's a way in which to support the ability for third-party vendors to come along and say, I've got a new engine here that can run models, on these kinds of sensors or these kinds of gateways out in the network, so that you can extend the reach of the model development environment that you've put in place in order to reach those new devices that you want to bring in and put to work within your organization. And of course, handle the ability to do in-flight integration of data and in-memory processing as well. So these are all kind of new things that we have to think about. But the key point being is that we are now starting to see the emergence of tooling that is allowing us to start to do that. The screenshots that I showed you a moment ago of statistical. So some questions to ask to get started with all of this might be things like, well, what kinds of events do you want to monitor in your core business operations? Are you trying to monitor product usage? Are you trying to monitor online behavior in real time with clicks and touches of mobile phone screens? What kind of models need to get built in order to be able to analyze that? And then how are you going to deploy those and execute those in the different environments within which they need to run? And do you know about what they all are? And then if you do know what those execution environments are, then, well, what kind of actions do you want them to take? If they do find an event correlation that indicates a business condition, and who gets notified, or what applications get notified if that occurs, and what actions should be taken? Is somebody responsible for that, or is this an automatic action? And when should it be taken? Should it be immediate? So, for example, in the case of a deep water oil well, if the integrity of that is threatened in any way, then the action's probably immediate. Shut it off. Completely shut it off. Then alert people. Then we'll deal with it after the action's already been taken, so that we don't get a repeat of the terrible disaster that I referred to earlier. And what possible actions could be taken if there's multiple actions which could be taken there any way to simulate that and determine which is the best one to take? And how are you going to centrally manage and maintain all of that? As your edge or as your network of things grows across your organization. These are all things to think about and to plan for. But certainly it's pretty clear that we're entering a new era to extend the reach of analytics, to work hard for us to keep our businesses optimized all the way out into the network and to prevent problems as well out there that could also impact our customers, and we want to make sure that they're happy and stay with us and don't suffer any dissatisfaction as a result of things that we just couldn't pick up. So with that, I think that kind of brings me to the end of this session. Just like to say many, many thanks. Got some contact details here if you want to contact me later. And I'll hand it back to Dave to see if we've got any questions. Dave?
All right, perfect, Mike. That was a fantastic presentation. Thank you so much. I'm going to just, share, from a Statistica brief infomercial, and then we'll get to the questions. But, our mantra really at Statistica is to embed analytics everywhere. So, just from a high level, we have technology that allows for in-database, in-gateway, in Hadoop, model deployment and execution and things like that. So if you have questions on our specific technology, please visit the website and check that out. We can help you out there. We also have other webcasts by Mike, so those are available on our website. So feel free to check that out. It's another great webcast. So with that, Mike, I'm going to start reading off some questions. We do have a lot of them, and so this is great. I'm going to start here. So Mike, you mentioned in the beginning that you said we're dealing with a data source that never stops, and you talked a little bit about having to maybe merge this with internal data. You have streaming data, and so the question was really around where does the analytics sandbox fit in, and is there room for an analytics sandbox in this environment? From a testing and deployment and these. The quote was, analytic models don't grow on their own. So any perspectives on the analytics sandbox?
Yes, well, I think if we're referring to the kind of sandbox environment where data scientists would potentially train models, as I said kind of at the beginning, there's no reason why you can't bring in streaming data into an environment like a big data environment and store that data there and then use it in a data science project to train models in order to be able to detect patterns within that data stream. And then once you train them, then you would deploy them out into a live streaming environment to be able to spot patterns. So in that case, I do think there is a role for the analytics sandbox here, which is that you're doing offline model development, but it's just that you're doing real-time deployment of those models into the edge, so to speak, in order to be able to continuously monitor and do their job out there. But also it's true that some of the actions that could be taken from those models could be to emit another event. And then you could have other bots or agents, if you like, looking out for those kind of patterns. And so there's no reason why you couldn't escalate problems if necessary. But in which case you may have to be looking at using a sandbox environment to build a family of models that are, being that may be looking out for different things, but are related in some way.
Okay, great. Thanks, Mike. And your schematic of the strategic, tactical, and operational monitoring agents, that kind of dovetails right into our concept of concentric analytics, and as you radiate outward in the network. You can do different kinds of analytics.
Yeah,
I'm going to get to another question here.
Sorry, yeah, go ahead.
Yep,
No,
go ahead.
that's fine. No, I was just going to say, certainly, the more you go out into the network, obviously, the thousands and thousands of decisions that could be made out there that may never make it to the middle because they don't need to. They can be detected and acted upon more locally, and so we get greater scale as a result of it.
Yeah, absolutely. Okay, this is an interesting question. Where are we, or how deep are we into the maturity curve for IoT?
I think we're right at the beginning. I think this is extremely young space. Of course, the industrial internet is here, and there's big companies like GE and whatnot driving a lot of that, Siemens and big companies like that driving a lot of that. And manufacturing has absolutely grabbed it big time, and so I believe it's pretty clear, that we're seeing smart everything emerging, all kinds of smart things, smart bridges, smart TVs, smart phones, smart homes. The whole thing is continuing to grow, but in the maturity curve, I think we're right at the beginning. We're a long way to go yet, and I think a lot of companies have not yet brought IoT into their implementation production environments at this stage. We're planning for it, or we'll go there in the next few years. I think we've got a lot of years yet to go.
I agree with you. This was an interesting question in terms of, you mentioned you started out with an airline example, and I think you said it had, 7.5 terabytes of data a day. And so the question is centered around, what do organizations typically do with this? Do they store it all? Do they throw it away? Or, what happens to this data exhaust, I guess? That's the question.
I guess it's going to be the organizations who are going to know that in detail and not necessarily revealing it all. But without a doubt, of course, the aircraft manufacturers, the engine manufacturers, the car manufacturers are going to get to see a lot of that data first. But you also have to look at the disruption value of that, the obvious things that would come to mind initially might be that manufacturers would get this data first and use it to detect problems and do maintenance, like airlines, for example, or aircraft manufacturers would be able to monitor the efficiency of the parts and everything that are in there, might even be able to offer services to airlines in order to be able to, to do what's called just-in-time engineering, where, assuming aviation authority regulation allows it, an engineer could be stood there at an airport gate as the aircraft arrives, having already found out that that there's a part on the aircraft that is safe to change in a minimum amount of time, and that part is predicted to fail, I don't know, in the next 100 flights or something like that. And so the engineer, during normal turnaround time, would potentially then be able to change the part, prevent the outage, and so keep the aircraft in the air rather than have to take it out of service. Of course, all within aviation regulations, but that's commercial value to an airline. But there's a further disruption value to it. If you take a car manufacturer, they're able to gather all the sensor data about how you drive, then why on earth would it not be possible for a car manufacturer to enter the motor insurance marketplace and disrupt insurance companies? If you are a wearable manufacturer, and whether it's making watches or various other devices that are monitoring our fitness, you could gather data about people, which could then be used to disrupt the life insurance market. And so you could get people who make these things entering a life insurance market, which is a totally different vertical industry, because they have the data to do it, and so can open up a completely different revenue stream on the back of the data that they collect. So, no question, all kinds of potential value here.
All right. Well, I appreciate that answer, Mike. And there is no shortage of opportunity, with the Internet of Things. So I think with that, we're just about over our time. So I want to thank everybody for attending today's webcast. I want to thank Mike for this great presentation. Just a reminder, we will be distributing the recording slides early next week. And so I want to thank everybody. Thanks for joining us, and have a productive day.
Thank you.